Good morning and welcome to the Prime Minister's Prize for Science breakfast live stream. My name is Paul Richards and I'm the Director of Communications and Outreach at the Australian Academy of Science. I'd like to start by paying respects to the Ngunnawal and Ngambri peoples, the traditional owners of the lands on which the Academy office is located. The Academy also acknowledges and pays respects to the traditional owners and the elders both past and present on all the lands on which the Academy operates and its fellows live and work. They hold the memories, traditions, cultures and hopes of Aboriginal and Torres Strait Islanders peoples of Australia. Well, what an evening last night, celebrating the best of science. Shortly, we'll be crossing to the Shine Dome behind me to recognise the recipients of the Prime Minister's Prizes for Science. We were thrilled to see another fellow of the Australian Academy of Science take out the Prime Minister's Prize for Science last night. Professor Trevor McDougall from the University of New South Wales received the honour for his outstanding contributions to the study of the world's oceans and their role in regulating the Earth's climate. The award recognises his groundbreaking research in the field of ocean thermodynamics, which looks at the role of the ocean in the movement of heat around the planet. This includes how to keep track of the heat that is exchanged with the atmosphere and how heat is mixed in the ocean interior. Trevor's achievement continues the pattern of the Prime Minister's Prize for Science being given to a Fellow of the Australian Academy of Science every year since 2000, the modern format of the prizes. We'll be catching up with Trevor and some of the other recipients of the Prime Minister's Prizes for Science a little later this morning. Then, from 9 a.m, we'll be streaming Science at the Shine Dome live. Tune in for free on the Academy's website, science.org.au. And as Lisa Harvey-Smith has recognised in her tweet, we're providing it for many reasons, including access, the health risks of in-person participation, and also climate change. You'll be able to witness the Fellows' admission ceremonies for the past 3 years. They'll sign the charter book, also signed by the late Queen Elizabeth and Prince Philip. And in between those ceremonies, we'll be talking to some of the Fellows who are signing that book. We'll learn more about their journey in science, the impact that they've had, and their ambitions as Fellows of the Academy. Well, it's cleared up here at the Shine Dome. It's a beautiful, sunny, shiny day, and it's going to be a great week. Unlike yesterday when there were wind gusts up to 70 kilometres an hour and the temperature only reached 12 degrees in November. But we're looking forward to a much calmer week and a true celebration of science. Let's take a live shot now inside the Shine Dome, where the Prime Minister's Prize for Science breakfast presentations are about to get underway. If you're just joining our live stream this morning, we are standing by to go to the presentations inside the Ian Walk Theatre of the Shine Dome, where the Prime Minister's Prize for Science breakfast is underway. And there are all sorts of dignitaries that have gathered, as well as the recipients of the Prime Minister's Prizes for Science. Of course, an incredible celebration at the event last night in the Great Hall of Parliament House, and just a fantastic turnout, and so wonderful to be gathering in person for the prizes, and then this morning here at the Shine Dome for our Prime Minister's Prize for Science breakfast. Stay with us and we'll be crossing live to the theatre as soon as formalities get underway.
A very good morning to you all. What a great joy to welcome you here to the Australian Academy of Science, and more particularly to the iconic Shine Dome. Thank you so much for being with us this morning. I'm seeing many faces who I was able to spend such a lovely evening with yesterday in the Great Hall of Parliament House, and what a celebration of science it was. To all of the prize recipients, it's lovely that you can be here this morning. I know you've been up since the crack of dawn with all of the media interest about your achievements, and rightly so. They really are very remarkable. For those who I've not met before, my name is Anna Maria Arabia. I'm the Chief Executive here at the Australian Academy of Science. I'd like to welcome all of our distinguished guests. I won't go through all of them because I think I would be naming everybody in the room, but a very particular welcome to Senator Walsh. Thank you for being here today, representing Minister Husic, the Minister for Science and Industry. To begin, I'd like to acknowledge the traditional owners of the land on which we're meeting, the Ngunnawal and the Ngambri people. It's upon their ancestral lands that the Australian Academy of Science is built. And as we share our knowledge, our teaching, our learning and our research practices, we also pay respect to the knowledge that is embedded within Aboriginal custodianship of country. It's so lovely to be celebrating in person the 2022 Prime Minister's Prizes for Science, and to be able to host this breakfast again, which is a lovely annual gathering following the prizes last night. Australian scientists are leading so many important conversations across our communities, and it's a privilege to be able to recognise them and their achievements here this morning. I'd like to thank Senator Jess Walsh for joining us, and the Department of Industry, Science and Resources for all of their hard work to bring together such a wonderful event yesterday, and for bringing us all together in what's shaped up to be an absolutely tremendous week to celebrate science and scientists. We also have an online audience, so I'd like to particularly welcome them. Thank you for joining us early this morning, and we look forward to your participation later today as part of Science at the Shine Dome. Before I invite the Academy President to provide his opening remarks, I ask attendees if they could please place their phones on silent if you've not already done so. But I do encourage you to take photos and celebrate the award winners. The hashtag for the Prime Minister's Prizes for Science is #PMPrizes. If you have a look, there are so many wonderful snaps from last night, and our ever-enthusiastic Minister for Science, who I think met everybody in the room most enthusiastically. We strongly encourage attendees to practice good hand hygiene, and we've made a hand sanitizer available throughout the venue, as well as face masks should you wish to wear one. Similarly, for everyone's comfort, we're going to forego handshakes this morning throughout the awards ceremony. There will be hundreds of people coming through this Shine Dome from all parts of Australia, and we're really conscious that we are going through a bit of a COVID peak. So now, to begin this morning's proceedings, I'd like to warmly welcome the President of the Australian Academy of Science, Professor Jagadish.
I promised the media people I'll switch on my microphone. Thank you, Anna Maria. And I also pay my respects to the traditional owners of the lands we meet, Ngunnawal and Ngambri people, to their elders past and present and emerging. And colleagues, it's an honor to welcome you to the Australian Academy of Science this morning. In my first year as Academy President, I could not have asked for a better start to my return, or my tenure, than our return to the Shine Dome here in Canberra, and to be celebrating scientific excellence here with you. I would like to extend a very warm welcome to the winners of the Prime Minister's Prizes for Science, members of Parliament, and all our esteemed guests here this morning. It's wonderful to be here to celebrate with you. Australian scientists are among the best and brightest minds in the world. As scientists, we are compelled to ask questions and seek answers to understand our world, and we look ways to better the future of our community, our nation, and our neighbors all over the world. This is what drives us, what moves society forward, and it is a calling. But answering call isn't easy. Questions are increasingly hard, and the answers sometimes harder. This is why it is important to recognize outstanding achievements in science and inspire future generations to continue asking questions and to innovate and create. This year, the Academy is very proud to be able to call the winner of the 2022 Prime Minister's Prize for Science a Fellow of the Academy. Scientia Professor Trevor McDougall was elected to the fellowship in 1997 and is recognized as the foremost world authority on many aspects of ocean mixing. He has significantly influenced modern understanding of the subject, and I am pleased to be here with this morning to honor him. And I was born in a rural town in India, and I should call it as a rural village in India, and my school was distant from my home. And if it weren't for my maths teacher in high school, who took me to enable me to stay with him to attend school, I would not have had the opportunity to be educated, and I certainly would not be at this podium today. It's likely I would have been plowing the fields in India like my cousins. I cannot thank our primary and secondary teachers enough, but the critical role you play to nurture and inspire the next generation. And all of us can relate to a teacher who has inspired us to be taking science as a profession for ourselves, and all of us relate to us, and thank you. As a nation, we are indebted to you. And as President of the Academy and someone who deeply understands the value of education, I personally thank you. Now, to formally open proceedings this morning, I invite Senator Jess Walsh to the podium.
Thank you very much. Good morning, everyone. I too would like to begin by acknowledging the Ngunnawal and Ngambri people, the traditional custodians of the land, and pay my deep respect to elders, both past and present. And as the Prime Minister and Minister Husic did last night, I too acknowledge the role of Australia's First Nations people as Australia's first scientists, based on their deep knowledge of the land, the waters and the skies. Thank you to Anna Maria and Professor Jagdish for inviting me here today on behalf of Minister Husic. It's really great to be at the home of the Academy. Thank you to colleagues who've joined from the House and Senate to join with us this morning. It is an absolutely enormous week for Australian science, and Minister Husic, who you all met with last night, sends his apologies for this morning and his best wishes. I'm really proud to be here on his behalf after an absolutely wonderful night last night. I was so struck as I listened to all of the reports of your achievements about the incredible enthusiasm and the energy that our science community has in Australia, the diversity, the focus on teamwork that you all spoke about, and the commitment to help people and the planet through science. And I know that there's a joke there about how similar that is to the culture of politics in Australia as well, but it's a little bit too early for me to make that joke. Last night really was an incredible celebration of all of that culture and all of that achievement in the science community. And it's great to see everyone back bright and early and looking forward to a coffee. This morning's event is a tradition where we can reflect on some big achievements in Australian science by our top scientists, innovators and teachers. And it provides an opportunity for those top achievers to receive a special acknowledgement from this most esteemed academy. Just like the awards themselves, this breakfast has been unable to go ahead face-to-face for a couple of years. So again, it is really wonderful that people can come together here at the Academy's home and celebrate and support excellence in Australian science. Thank you very much to the Academy for your efforts in hosting this event and for championing Australian science for more than 60 years. Thanks must also go to the Department of Industry, Science and Resources for making last night's celebration happen. I know it was a huge undertaking to produce what was an absolutely inspiring event. Most importantly, thank you to the prize recipients and the highly commended in all the categories. Your work is truly outstanding. And you're doing your part to inspire our next generation of scientists as role models, as mentors, as teachers, and as leaders in your diverse disciplines and pursuits. And as a government, we want to back that work up. So rest assured that the government is also committed to encouraging Australians from all corners of the community to study and work in STEM-related fields. And as Minister Husic said last night, and this was one of the parts of the speech that he actually stuck to. As he said last night, it's absolutely critical that we boost science literacy and the engagement with science of all Australians because it's so fundamental to so many areas of our lives. So as a government, we are really proud to back science and scientists. We want to actively promote your contributions. And we want to build a culture of respect for science in our community. And our efforts to do all of that feel incredibly rewarding when we can look out at a room like this one and see diverse, inspiring, life-changing achievements unfolding before us. So, once again, huge congratulations to you on all of your achievements. Huge congratulations on your contribution to Australia's scientific community, to our economic success as a country, to our quality of life and our well-being, and also to the pure joy and wonder that scientific discovery creates. Thank you.
Thanks so much, Senator Walsh. And thank you for echoing the Prime Minister's and the Science Minister's words last night. I'm sure I wasn't the only one in the room who felt very encouraged to hear, and I must say not for the first time, a commitment by both the Prime Minister and the Science Minister, not just to the commercialisation and translation of research, which is fundamentally important, but to the discovery science that underpins that. It is really very refreshing to hear an appreciation of that entire pipeline of research that's needed to keep our research enterprise going and contributing to the many, many problems that we need to solve across the globe and right here in Australia. So one of the key reasons we have this breakfast is, yes, to bring everybody together. But of course, last night, the prize winners were handshaking and meeting lots of people and holding their medals and awards, and there wasn't a spare hand for a certificate. And so we're able this morning to give each of the prize winners their certificates and also honour some additional people who have been part of the Prime Minister's Prizes for Science in 2022. So it's now my pleasure to introduce each of the Prime Minister's prizes recipients. The first prize this morning is the Prime Minister's Prize for Science, and I invite the 2022 winner, a Fellow of the Australian Academy of Science, Science Year Professor Trevor McDougall, up to the stage. Congratulations, Trevor. And as with all of our fellows who give so much of their time and energy to the Academy, I'm particularly indebted for your contribution some years ago to leading a report that this Academy published around the climate change capability across our research workforce in Australia. It was a seminal document and continues to be a reference document for us to understand what capability we need in this country to deal with climate change. So thank you. The Prime Minister's Prize for Innovation. This year there are 2 winning teams. The first team that I'd like to invite to the stage is the Photon Assay team, including Dr. Nick Cutmore, Dr. James Tickner and Mr. Dirk Treasure. Oh, there are 3. The second team I'd like to invite to the stage is the SpeedX team, and that's Dr. Elisa Mockany and Adjunct Professor Alison Dodd. Congratulations. Our next prize is the Malcolm McIntosh Prize for Physical Scientists of the Year. Please welcome the 2022 winner, Dr. Adele Morrison. I would now like to call the winner of the 2022 Frank Fenner Prize for Life Scientist of the Year to the stage to accept their award, Professor Si Ming Man. One of the privileges here at the Academy is to house unique scientific collections. We have historic collections for some 200 fellows, and some of their important work and notebooks and things are here and are slowly being digitised so that they can be accessed anywhere around the world. They can, of course, be accessed in person here at the Shine Dome. We have the great privilege of having Frank Fenner's diary, which he kept, including the diary he wrote when he declared smallpox eradicated at the World Health Organization conference. He wrote of his bus trip to that conference. He wrote about the weather that day, and he wrote about declaring smallpox eradicated, that minor event. I often reflect on that moment when one day someone might stand at the World Health Organization conference and declare SARS-CoV-2 eradicated from our society. It is a very important collection. It is one that is digitised, so you're welcome to have a look through the National Library of Australia's Trove or via the Academy website. Small plug for our collections. I'd now like to invite the next winner for the prize for new innovators. This year there are 2 winners. The first winner is Associate Professor Brett Hallam. I do encourage you to go online and have a look at the videos of the award winners. They are absolutely inspiring. I was very struck by your work, Brett, on solar panels and the reach it's had across the world. I'd now like to invite the second winner of the prize for new innovators, Dr. Philibel Pip Caroli, to the stage to accept her award. Now, I don't know about you, but whenever I hear about the work of our teachers, our primary and secondary teachers, I well up, I get quite emotional because they are absolutely inspiring. Last night was no exception at all. In fact, I don't think there was a dry eye in the room when the award was accepted from the Prime Minister's Prize for Science Teaching in Primary Schools. The winner in 2022 is Mr. George Panzanis from Marble Bar Primary School in Western Australia. A very special thank you to you, George, for the work you've done with Indigenous communities and the enormous cultural sensitivity you've shown in working with those communities is absolutely tremendous. The Prime Minister's Prize for Excellence in Science Teaching in Secondary Schools this year is awarded to Ms Fiona Nair from Viewbank College in Victoria. And thank you, Veena, for all the work you do to shepherd those curious minds through our education system. I hope that some of your students might one day be at this podium accepting an award or fellowship of the Australian Academy of Science. Later this morning, we will be admitting to the Academy fellows elected in 2020, 2021 and 2022. So it is a very special day for us, and indeed may some of those students join them one day, and others, many of the prize recipients who may not yet be fellows of the Academy. We'd now like to present certificates to our highly commended teachers in the category for science teaching in primary schools. Congratulations to Miss Sophie Poisel from Linfield Learning Village in Sydney, New South Wales. Sophie, if you could please come to the stage. Sophie's not here? No? It's not here. We'll send her her certificate in the mail and congratulate her on another occasion. And also in the category for science teaching in primary schools, we congratulate Mr. Daniel Edwards from Montello Primary School in Tasmania. Congratulations, Daniel. And in the category of science teaching in secondary schools, congratulations to Mr. Michael Parkasis from Strathmore Secondary College in Victoria. In the category of science teaching in secondary schools, congratulations to Miss Karen Palumbo from Henley High School in South Australia. And our final certificate is to Mr. Lachlan McGuinness from Canberra Girls Grammar School here in the ACT. A very warm congratulations to all of the highly commended teachers and indeed all of the winners of the 2022 Prime Minister's Prizes for Science. That brings this morning's formal proceedings to a close, and I invite you all to join us for breakfast in the Jaeger room, which is just outside of the building. If you go out the wrong entrance, keep walking, you'll not get lost in our circular building. Before we do so, could I ask all of the recipients to gather in the foyer for a group photo? It's been an absolute pleasure to have you here this morning and to celebrate excellence in science and in teaching. And on behalf of the Australian Academy of Science, thank you for visiting us here at the Shine Dome. Please enjoy a well-earned cup of coffee or tea. Good morning.
Well, good morning. My name is Paul Richards and I am the Director of Communications and Outreach at the Australian Academy of Science. Well, history has been made once again after another spectacular evening of the Prime Minister's Prizes for Science. Congratulations to all the recipients. Shortly, we'll be joined by Fellow of the Academy, Professor Trevor McDougall, who was awarded the Prime Minister's Prize for Science at the spectacular ceremony last night. But first, we're going to take a look at what earned him this fantastic recognition.
I'm Trevor McDougall. I'm Scientific Professor of Ocean Physics at UNSW in Sydney. I do research in the ocean's role in climate and climate change, and I work on ocean mixing processes and the thermodynamics of seawater. So ocean mixing is like stirring milk into your coffee. It's turbulence, and the ocean has a variety of different processes at work. And thermodynamics is the study of where heat goes, how the ocean interacts with the atmosphere and where that heat goes inside the ocean. So an example of that is that we need to keep track of the heat transfer around the ocean, and we've always done that for a century using potential temperature, which is the temperature a parcel of seawater would have when moved to the sea surface. One day I was swimming before breakfast and it came to me to try a different variable. And now that temperature variable has been adopted internationally as the way of representing temperature and heat in marine science, and it's a factor of 100 times better at doing that than our previous potential temperature. With colleagues, I've also developed software which enables oceanographers around the world to determine these mixing directions in their own data. To receive the Prime Minister's Prize for Science is an incredible honour. It also is an honour for the early career researchers that I've been working with the last 10 years, and they've been really integral to some of the results that have been recognised in this prize. It's really great that the field of oceanography and climate science has been recognised in this way, because we need these sciences more than ever in the future to understand how the planet is and will evolve with time.
Well, it's an absolutely spectacular morning here in Canberra outside the Shine Dome. All of the wind and the wild weather of yesterday has blown away, and we are now sitting in beautiful sunlight outside the Shine Dome. We've got an incredible day ahead with Science at the Shine Dome coming up a little later this morning, but we have just finished proceedings in the Prime Minister's for Prize breakfast here at the Shine Dome, and have been recognising all the recipients of the Prime Minister's Prizes for Science. One of those recipients is Dr. Adele Morrison. She received the Malcolm McIntosh Prize for Physical Scientist of the Year, recognised for her pioneering research on Southern Ocean warming. Let's take a look at her research.
My name is Adele Morrison. I'm a physical oceanographer at the Australian National University. Science has always been a part of my life, from studying physics at university to teaching maths and physics at high school, and then coming back to doing research in oceanography. One of the things I love about science is being able to apply problem solving to real-world problems like climate change. My work aims to understand the impact of changes in the ocean on climate and sea level. I use high-resolution ocean models to understand what drives the ocean circulation and how it will change in the future. One focus of my work is to understand how the ocean influences Antarctica. Antarctica is the largest ice sheet on the planet and has the potential to raise global sea level by up to 30 centimetres by the end of the century. Antarctica is a remote and challenging location to take observations. My work using modelling allows us to fill in the gaps in those observations to understand the complex system of ocean circulation around Antarctica. These include rotating flows called eddies and descending waterfalls of dense water at the bottom of the ocean. By understanding these features, it allows us to create more precise projections of sea level rise coming from Antarctic ice melt in the future. This knowledge is absolutely critical to allow us to mitigate and adapt to climate change in the years to come. The Southern Ocean plays an important role in the climate system by taking up huge amounts of heat and carbon from the atmosphere and therefore limiting the effects of global warming. The reason the Southern Ocean can take up so much heat and carbon is because of the upwelling of cold, deep waters to the surface. My work using high-resolution modelling has helped us to unravel the complex dynamics of the upwelling circulation and how it will respond to climate change. This work could not have been possible without a great team. To receive the Malcolm McIntosh Prize for Physical Scientist of the Year is an amazing honour and a great opportunity to raise awareness of important issues like climate change. I hope I can be a role model for girls and young women to show that it is possible to have a wonderful life both inside and outside of science. I hope my work can inspire the next generation of scientists to unravel new discoveries and technologies to limit the impacts of climate change and transition us to a zero-emission world.
Well, good morning and welcome if you're just joining me. My name is Paul Richards. I'm the Director of Communications and Outreach at the Australian Academy of Science. We've just wrapped up the Prime Minister's Prizes for Science breakfast here at the Shine Dome. The Frank Fenner Prize for Life Scientist of the Year was given to Professor Si-Ming Man. He was recognised for advancing our understanding of inflammation as an underlying mechanism of health and disease. Let's take a look at Professor Si-Ming Man's research.
My name is Si-Ming Man. I'm an immunologist at the Australian National University in Canberra. When I was 8 years old, I remember asking my mum to take me to see Jurassic Park because I really wanted to be a biologist. Ever since then, I knew I really wanted a career in science. I lead a team of scientists at the ANU. We have found that different senses, much like different alarm systems, are activated within our body in response to different types of infections. And these responses can trigger inflammation, which help our body to eliminate and destroy different types of harmful germs, including bacteria and viruses. Our research shows that too much inflammation is harmful for the body because it can lead to sepsis and different types of cancer, like bowel cancer. Based on our research into inflammation, we are able to harness the most active part of the immune system and turn them into drugs. We found that these drugs are very effective in killing harmful germs. Our research makes a significant impact in improving the quality of our lives, especially for people in our community who are at the greatest risk of catching an infection. We are now on track to develop new and innovative therapies that harnesses the immune system to fight against all sorts of diseases, including infection and cancer. We will share our data with policymakers to develop new measures, creating a future of better health for all Australians. With CSIRO, we are now testing our drugs against bacteria which came from our food, our farm and our soil. I'm really excited that our work extends beyond medical research and to help find solutions to combat diseases affecting our agricultural and food industries. It's an incredible honor to be a recipient of the Frank Fenner Prize for Life Scientist of the Year. This prize will continue to inspire me and other young scientists to dream big and to take risks with our research to solve big problems.
And of course, the Prime Minister's Prizes for Science have always recognised excellence in science teaching. Mr. George Pantazis was recognised with the Excellence in Science Teaching in Primary Schools award. Mr. Pantazis is the STEM coordinator at Marble Bar Primary School in Western Australia. Let's take a look at his story.
My name is George Pantazis. I'm the STEM coordinator and learning support teacher at Marble Bar Primary School, located in Marble Bar, Western Australia. The population of Marble Bar is approximately 157 people, and at Marble Bar Primary School, we have approximately 25 students. It is famous for being the hottest town in all of Australia. At Marble Bar Primary School, I lead the integrated STEM program that combines Western pedagogies and Aboriginal cultural knowledge. We use two-way science, where the students become the teachers and they teach us about their rich Aboriginal culture. This is wonderful because First Nations science is the oldest science in the world. We use 21st century technology to acknowledge, respect, and celebrate First Nations culture. These technologies include virtual reality, drone aviation, and First Nations science and art. We've used virtual reality to take our integrated STEM program to the rest of the world, such as Europe, the United States, and Asia. More importantly, what this did was promote and celebrate our First Nations culture to the world. One of the most significant projects of the integrated STEM program is the digital First Nations seasonal calendar. The calendar depicts the seasons of the local region of the East Pilbara. Our next project is to create the first culturally appropriate video game, which links our First Nations culture and two-way learning. To be recognized in the Prime Minister's Prizes for Science is not about me. It's about my students, showcasing the First Nations culture and preparing them for their future.
And let's take a look at the final story for one of the Prime Minister's Prizes for Science recipients who we'll be catching up with a bit later this morning. Veena Nair was recognised for excellence in science teaching in secondary schools. Let's take a look.
My name is Veena Nair and I am the Head of Technology and STEAM Project Leader at Weirbank College in Melbourne. We run a lot of curricular and co-curricular activities. We offer emerging technologies such as 3D printing as a curriculum option for students from Year 9. Teachers are our nation builders and we want our teachers to introduce our students to these emerging technology skills. Many people know about STEM, science, technology, engineering and maths. But STEAM is with an A, which is for arts. It brings in out-of-the-box thinking and it brings in creativity for students. Students need STEAM skills to innovate, to become resilient and to take risks. One of our successful initiatives is the STEAM Club. STEAM Club offers students an opportunity to become change makers and use their skills for the greater good. As a part of the STEAM Club, we've started an initiative called the STEAM Futures Conference, where students, teachers and industry from Victoria come together and develop new emerging technology solutions and lesson plans that can be incorporated in every school. One of these initiatives is the Young Person's Plan for the Planet. This initiative allows students to use their STEM skills and enterprise skills in developing solutions for global and local problems along with their peers in different countries. The Swinburne Youth Space Innovation Challenge offers our students a unique opportunity to work with space scientists in developing experiments that can be sent to the International Space Station. I've seen a large number of students take up engineering after doing VC systems engineering, especially females. To be recognized in the Prime Minister's Prizes for Science, I'm deeply humbled. I'm very grateful to my school, to my colleagues, to my students, and to my family.
And Professor Trevor McDougall has joined us now, the recipient of the Prime Minister's Prize for Science. Professor McDougall was recognised for his outstanding contributions to the study of the world's oceans and their role in regulating the Earth's climate. The award recognises his groundbreaking research in the field of ocean thermodynamics, which looks at the role of the ocean's movement of heat around the planet. This includes how to keep track of the heat that is exchanged with the atmosphere and how heat is mixed in the ocean interior. Professor Trevor McDougall, good morning to you.
Thank you.
What did you think when you first found out that you were the recipient of the Prime Minister's Prize for Science?
Well, first of all, my wife said, well, you've got a missed call from the Minister for Science. He must be calling you to say you're the runner-up. So that's what wives are for, to keep you humble.
Just to keep us on an even keel.
That's it. That's it. Yeah, so I work on the ocean's role in climate, in particular ocean mixing. And it's like stirring milk into your coffee. And the ocean has less dense water at the top and more dense at the bottom. And it's actually 10 million times easier to mix horizontally than vertically. And getting the angle right, the surface in which the mixing, strong mixing happens, is really a difficult thing to do, and it's what I've been working on for quite some time.
How did you lead up to this discovery? What prompted you to start looking at the discovery that you ended up making?
Well, I think the thing is to leave some time in your career to not just do the things you know how to do and publish a series of papers, but to tackle the difficult things, the things that other people have tried and failed or turned away from. And so you give them a crack and see whether something from your background, from your knowledge, can work. You come to this with a bag of tricks, and I came to oceanography with a bag of tricks that was a little bit different to most people, because my background was engineering, and so I had a bit more thermodynamics than my colleagues, and I think that might explain some of the ability to make some breakthroughs that others didn't get to.
And another great example of the need for lots of different backgrounds, cross-disciplinary research, to be able to bring that knowledge and that understanding to another area. Do you think that was key in your discovery?
Exactly, that's right. So I was able to bring that understanding or give something a crack that was different to the normal way of tackling the problem. So the ocean's really important in climate. 92% of the extra heat that the planet has received from greenhouse warming is in the ocean, and it's to the ocean that we look to get measurements of how fast the planet is warming. And so everything the ocean does, from mixing to interaction with the atmosphere, is vitally important for where CO2 gets sucked into the ocean, where the heat gets transported, and how fast the ice shelves are melting. That's a key. I mean, in ice ages, all the rise and fall of sea level comes from melting those ice shelves that are on Antarctica. And the processes are limited by the amount of warming in the ocean that can undercut these shelves.
And I've read that you've described the oceans as like the flywheel of climate change. Can you explain that to me? How? Because there's so much heat that is actually trapped.
That's right. It's actually doesn't take much heat at all to warm the atmosphere, but to warm the ocean takes much more heat. And so that's why 92% of the extra heat the planet has received is in the ocean. The heating signal doesn't penetrate very far on the solid Earth, and it doesn't actually take too much heat to melt some ice. Because it's happening slowly by comparison. But to warm up 500 meters of seawater takes a lot of energy. Just think of the amount of energy it takes to warm your kettle.
And the variable that you have worked out how to measure, that has made a huge change in the way that how accurately we're able to measure the transfer of heat throughout the oceans. Can you tell me a bit about the process behind that discovery, but then also just how accurate, how that improved accuracy?
Yeah, so we're conducting nature's, humans' biggest experiment on planet Earth. That's called climate change, greenhouse warming. So it makes sense to be able to track heat accurately. And for a century we were doing it approximately, and we didn't really have any leads in how to do that. So I'd spent a few days worrying about perhaps a more accurate way of doing it. I would have been happy with a factor of 2 improvement. But I was swimming one day in this before breakfast, and the idea came to me to instead of having a thought process of taking a fluid parcel to a fixed pressure and asking what the temperature is there, that's what we've been doing for a century. I thought, let's keep the same thought process, but instead of asking what the temperature is there, we'll ask what the enthalpy is. That's the thermodynamic measure of heat. And so probably others had thought of enthalpy, but it's a dumb variable by itself. The key thing is to add this thought process to it. And I was able to convince myself by morning tea that day that that was a good idea. But it took another 9 years to prove it. And then another 9 years to actually get the all the countries of the world to agree this was a smart thing to do. So it just puts that issue to bed, and we can concentrate on other difficult problems in climate.
And I mean, you said it there in terms of 18 years from first thinking this could be a good direction to go to proving it and then making it accepted. What a journey, and it really sort of demonstrates that science doesn't happen overnight. It needs long-term capacity and support to exist.
Yeah, it's interesting because, you know, 100 years of approximation that we all accepted good enough. I can prove to myself that this was going to be a goer in 3 hours, you know. But to bring on the world took some time. It's a bit of a sales job.
How is the temperature variable used now in research?
It's used. It is the variable to measure both temperature and heat content in marine science, and so it's the variable that ocean models carry that interacts with the atmosphere. It's the variable when we go to sea, we interpret all our data in terms of that variable. It's just a new temperature variable, so you just put the old one to bed and move on.
Okay. Now, you chaired the Academy's review of our climate science capability in 2017. It found that there were around 420 dedicated climate scientists across all of Australia's universities and research agencies at that time. You said in your award video that we need the kind of science you do more than ever. How's Australia tracking in our own climate science capability, especially when you consider Australia's responsible for climate modelling and understanding for most of the Southern Hemisphere?
Well, I'll take you up on the last point. I think it'd be really good if Australia took on board as something to deliver to the hemisphere the ability to actually be the best at projecting climate and its impacts in the whole hemisphere, because our weather is sort of hemisphere dependent. And there's no reason why, being the most developed country scientifically in this hemisphere, we shouldn't take that. We should take that on. How are we tracking? Well, I think the universities since that time have stepped up in terms of their fundamental interest in this subject, and I've certainly found that in my support at UNSW Sydney, which has been fantastic. I think our government agencies have stepped back a little from that, and they've been more dominated by their earnings potential, and I think that needs to change. I think the Bureau of Meteorology is and can do a better job of connecting the dots between weather and climate change, and I think the CSIRO has to have a bit of a rebalance between the fundamental breakthroughs that it used to fund and the applied research, which it'll always be known for and be good at.
Okay. Now, Trevor, you've been a Fellow of the Australian Academy of Science for 25 years now.
Thanks for counting.
I did look it up. That's a terrific achievement in itself. What has being a Fellow of the Academy meant to you, and what does it mean to you today?
It does carry responsibility to promulgate science and to be an advocate, to be a role model, if you like. It also means you have some responsibilities on committees that require your expertise for the government, and of course, perpetuating with recognising talent and recommending new fellows. But yes, it's a pinnacle of achievement for an Australian scientist, and it's a measure of respect or honour, but mostly it's an opportunity to continue that for the next generations.
Well, Professor Trevor McDougall, congratulations once again. It's a great pleasure spending some time with you this morning, and thank you for being with us.
Thank you very much.
Thank you.
Cheers.
Well, we're going to be catching up with more recipients of the Prime Minister's Prize for Science very shortly, but why don't we take a look once more at Professor McDougall's work, and we could have a look at the video that really summarises his role in climate science.
I'm Trevor McDougall. I'm Scientific Professor of Ocean Physics at UNSW in Sydney. I do research in the ocean's role in climate and climate change, and I work on ocean mixing processes and the thermodynamics of seawater. So ocean mixing is like stirring milk into your coffee. It's turbulence, and the ocean has a variety of different processes at work. And thermodynamics is the study of where heat goes, how the ocean interacts with the atmosphere and where that heat goes inside the ocean. So an example of that is that we need to keep track of the heat transfer around the ocean, and we've always done that for a century using potential temperature, which is the temperature a parcel of seawater would have when moved to the sea surface. One day I was swimming before breakfast and it came to me to try a different variable. And now that temperature variable has been adopted internationally as the way of representing temperature and heat in marine science, and it's a factor of 100 times better at doing that than our previous potential temperature. With colleagues, I've also developed software which enables oceanographers around the world to determine these mixing directions in their own data. To receive the Prime Minister's Prize for Science is an incredible honour. It also is an honour for the early career researchers that I've been working with the last 10 years, and they've been really integral to some of the results that have been recognised in this prize. It's really great that the field of oceanography and climate science has been recognised in this way, because we need these sciences more than ever in the future to understand how the planet is and will evolve with time.
One of the Prime Minister's Prize for Science recipients is Dr. Adele Morrison. She received the Malcolm McIntosh Prize for Physical Scientist of the Year, recognised for her pioneering research on Southern Ocean warming. Let's take a look at her research.
My name is Adele Morrison. I'm a physical oceanographer at the Australian National University. Science has always been a part of my life, from studying physics at university to teaching maths and physics at high school, and then coming back to doing research in oceanography. One of the things I love about science is being able to apply problem solving to real-world problems like climate change. My work aims to understand the impact of changes in the ocean on climate and sea level. I use high-resolution ocean models to understand what drives the ocean circulation and how it will change in the future. One focus of my work is to understand how the ocean influences Antarctica. Antarctica is the largest ice sheet on the planet and has the potential to raise global sea level by up to 30 centimetres by the end of the century. Antarctica is a remote and challenging location to take observations. My work using modelling allows us to fill in the gaps in those observations to understand the complex system of ocean circulation around Antarctica. These include rotating flows called eddies and descending waterfalls of dense water at the bottom of the ocean. By understanding these features, it allows us to create more precise projections of sea level rise coming from Antarctic ice melt in the future. This knowledge is absolutely critical to allow us to mitigate and adapt to climate change in the years to come. The Southern Ocean plays an important role in the climate system by taking up huge amounts of heat and carbon from the atmosphere and therefore limiting the effects of global warming. The reason the Southern Ocean can take up so much heat and carbon is because of the upwelling of cold, deep waters to the surface. My work using high-resolution modelling has helped us to unravel the complex dynamics of the upwelling circulation and how it will respond to climate change. This work could not have been possible without a great team. To receive the Malcolm McIntosh Prize for Physical Scientist of the Year is an amazing honour and a great opportunity to raise awareness of important issues like climate change. I hope I can be a role model for girls and young women to show that it is possible to have a wonderful life both inside and outside of science. I hope my work can inspire the next generation of scientists to unravel new discoveries and technologies to limit the impacts of climate change and transition us to a zero-emission world.
And Dr. Adele Morrison joins us now. Good morning, Adele. Thank you for coming along.
Good morning, thanks.
And congratulations. Now, climate science, oceanography is really having a bit of a moment at this year's Prime Minister's Prize for Science. Tell us a bit about the research that you've done in this area.
Right, so I guess my work uses high-resolution ocean models to try and understand the ocean's impact on climate and sea level. Mostly I study around the Southern Ocean and Antarctica. So I've looked at in the Southern Ocean, which is part of the global overturning. And so this is really important for taking up heat and carbon into the ocean. And so my work has looked at when you include all the small scale features of the ocean, so tiny eddies and things, what effect this has on how that circulation might respond to climate change in the future. And then the other part of my work has been looking at the warm water that comes up underneath the ice shelves in Antarctica that's currently causing the melting of Antarctica, and then trying to look into the future to see, again, once we include these really small scale processes, how does that impact our projections for ocean temperature and melting of Antarctica in the future?
How long have you been working in this area, and how have you seen the results change over time?
I guess about a decade now, I'd say. How the results change over time. So I guess in terms of my work, there's so much we don't know about the Southern Ocean and the ocean circulation around Antarctica. Like it's so hard to get ships down there to find out what's going on. It's covered by sea ice for most of the year. And so I guess as supercomputers have gotten larger, which has happened sort of over the last decade or two, we've really been able to fill in the gaps in these observations, so run really high resolution models to try and understand more of that dynamics that we just can't really get from observations because the observations are so sparse in time and space. So yeah, we've been able to make a lot of really new exciting discoveries by pushing these ocean models to much higher resolution than we were able to.
And you mentioned there supercomputers. How crucial is having access to supercomputers for the work that you do? It's fundamental.
Yes, my work would not be possible without a supercomputer. So, for example, like our ocean model, that some of those nice visualizations that you saw in the video before, we run that on about 10,000 cores on the supercomputer. So there's a very large simulations that we're running, and so yeah, couldn't do it on a desktop.
I was going to say, if I think about my own computer, I have maybe 4 cores, I think.
Yeah, yes.
So it's a few more.
Yes.
Yeah, okay, and so crucial in understanding what's happening in the impact of climate change. I mean, we really wouldn't be able to have those sorts of results without that research. For those who may not know, why is it important to understand why and how the Southern Ocean is warming?
So I guess the ocean at the moment takes up more than 90% of the total extra energy in the climate system due to climate change. And most of that heat actually enters the ocean via the Southern Ocean. So about 75% of ocean heat uptake occurs in the Southern Ocean. And so it's just vital that we can understand how the circulation is going to change in the future, like whether the ocean will keep taking up heat in the future, or if more of that heat would remain in the atmosphere, and then which might have more of an effect on us. And also in terms of sea level. So knowing how much of Antarctica is going to melt in the future helps us adapt to rising sea level. So it's, in 30 years we're going to be seeing, I think it's like 100 times the frequency of coastal erosion events. So when you get a big storm combined with a high tide, and then if you're adding sea level rise on top of that, these events that used to happen maybe once in a century will be happening every year. Only sort of by 2050 or so. So by understanding and getting better projections, we're able to help people figure out how we're going to adapt to those kind of extreme events, where to build seawalls or where we might actually need to move things back from the coastline.
What's it like as a scientist at the forefront of research into climate change, seeing the effects happening in the world as you're understanding them as well? Do you despair that the world isn't moving fast enough?
It's very scary, especially since we've known about climate change for so long. We've been telling governments for that this is something that we need to act on. So I'm glad that our government now has a path to get us to zero emissions by 2050. That's gives me hope. But I do think we've left it too late, and so I think going into the future, it's going to be even more important to not just get our emissions to zero, but actually go to negative emissions and start taking CO2 out of the atmosphere, developing new technologies that would allow us to actually sort of reverse some of that impact we've had on the climate system.
Yeah, my understanding is that those technologies to remove CO2 emissions are really, it's not an and or, it's both, is what we need, both in terms of taking carbon out of the economy and the amount that we're putting into the atmosphere, but also finding ways to remove it.
Yeah, for sure. So I think at the moment, with the trajectory we're on, it looks like we're not going to be able to stick to the 1.5 degrees or 2 degrees Celsius of the Paris Agreement. And so we're really going to need these negative emissions technologies. And those technologies don't really exist at the moment to the scale that we need them to be. And these include simple things like planting trees, which has problems, due to fires and the amount of land we have available. And so I think scientists are developing investigating other possibilities, like growing kelp in the ocean or sort of mineral ways of extracting CO2 out of the atmosphere. But we do need more investment in those negative emissions technologies.
Well, I was talking to our policy team just last week about this issue, and they were saying in terms of tree planting, Australia would need something like 7 Tasmania's worth of trees planted for it to have the sort of impact that is needed, which obviously is impractical to rely on alone. Not to say that tree planting shouldn't be part of the solutions, but we need investment in those technologies, don't we?
Definitely, yes.
Yeah. Yep. Now, Professor Trevor McDougall obviously works in a similar sort of field to yours. How do you know each other, and were you in contact when you discovered that you were a recipient of the Prime Minister's Prize?
Yes, yeah, it's so exciting to have both Trevor and I receive prizes this year. I'm not sure there's been any oceanographers receive these prizes before, and then 2 physical oceanographers in 1 year is very exciting. It was a fun night last night with lots of our supporters there to help us celebrate.
Yeah, fantastic.
Yep.
And just tell me, in terms of your own career and journey, you're an early sort of mid-career researcher. In terms of the makeup of scientists, are there role models that you look towards? Is there a need for more women to be attracted to the sort of work that you do?
Definitely, yeah. I think, I guess I did physics in my undergrad, and I think at that stage there were 2 female professors at physics at ANU out of 40 or so. So yeah, and there are very, very few role models that I had as a student, and so I think it's so important that we're able to provide more role models so students can look up and see someone that might be like them, to see that it's a possible career. Even things like being able to take parental leave and then come back to science afterwards, having that be an accepted culture, to look up and see people that have done that, I think is so important. Yep.
Terrific. Well, Adele Morrison, thank you very much for spending some time with me this morning. Congratulations once again.
Thank you.
Thank you. Well, shortly we're going to be meeting another recipient of the Prime Minister's Prizes for Science, the recipient of the Frank Fenner Prize. Professor Si-Ming Man has received this award for advancing our understanding of inflammation as an underlying mechanism of health and disease. Let's take a look at his research.
My name is Si-Ming Man. I'm an immunologist at the Australian National University in Canberra. When I was 8 years old, I remember asking my mom to take me to see Jurassic Park because I really wanted to be a biologist. Ever since then, I knew I really wanted a career in science. I lead a team of scientists at the ANU. We have found that different sensors, much like different alarm systems, are activated within our body in response to different types of infections. And these responses can trigger inflammation, which help our body to eliminate and destroy different types of harmful germs, including bacteria and viruses. Our research shows that too much inflammation is harmful for the body because it can lead to sepsis and different types of cancer, like bowel cancer. Based on our research into inflammation, we are able to harness the most active part of the immune system and turn them into drugs. We found that these drugs are very effective in killing harmful germs. Our research makes a significant impact in improving the quality of our lives, especially for people in our community who are at the greatest risk of catching an infection. We are now on track to develop new and innovative therapies that harnesses the immune system to fight against all sorts of diseases, including infection and cancer. We will share our data with policymakers to develop new measures, creating a future of better health for all Australians. With CSIRO, we are now testing our drugs against bacteria which came from our food, our farm, and our soil. I'm really excited that our work extends beyond medical research and to help find solutions to combat diseases affecting our agricultural and food industries. It's an incredible honor to be a recipient of the Frank Fenner Prize for Life Scientist of the Year. This prize will continue to inspire me and other young scientists to dream big and to take risks with our research to solve big problems.
And Professor Si-Ming Man joins me now. Good morning to you, and congratulations.
Good morning, and thank you.
Tell me, just to start off with, what got you interested in looking at the way that harnessing the immune system to fight infectious disease?
I think what really got me interested is understanding how powerful the immune system is and all the different amazing facets the immune system can do to basically defend us from birth until we die. And so the idea came about, well, if the immune system is so crucial, how can we then get the most out of the immune system to fight all sorts of diseases, including infection and cancer?
And tell us a bit about what you've discovered in terms of how to do that.
Yeah, so the award is recognizing the discovery that well, there are several facets. The first is we discovered the underlying process of how inflammation can be initiated. So there are these amazing sensors or alarm systems within our body which can detect different types of germs or pathogens, and they trigger very different protective responses. So that's one. The second part is that if you have too much inflammation, it could drive the process of causing cells to divide uncontrollably. That means that can lead to devastating diseases like cancer. And then, so the next part was to understand what's the most important part of the immune system and how to harness the power of the immune system to treat diseases. So for example, we identified a family of these killer proteins, which we know that can attack the pathogen. And so we took the most active part of those proteins and turned them into drugs or peptides to destroy all types of different pathogens.
How exciting is that when you make not only those discoveries, but that you're able to come up with a solution that's really changing people's lives?
It is, because we are changing the way of how we might approach treatment. Currently, we're treating infection with antibiotics, and that has led to a rise in antibiotic resistance. And so it is estimated by 2050 there will be more than 10 million deaths per year due to multi-drug resistance. So we need to do something now, urgently. And so one of the ways we can do that is, can we move away from antibiotics and look at our own immune system, because we can naturally defeat these pathogens, right? So then the idea was to see what are so good about our immune system, what's the killing power of it, and then harness it potentially in a pill to destroy those type of pathogens.
Such brilliant work. And you must work with quite a team of people in terms of doing this kind of research. Give us a bit of an insight into what kind of a team it takes to do the sort of research that you do.
Yeah, so we have a medium to large size labs, around 12 individuals, very talented. They range from postdoctoral fellows who have received their PhD all the way to undergraduate students, so just beginning. So it's about inspiring those younger generation to come up and see how the more senior people do it, and train them throughout this process of critical thinking and analytical skills, and try to build them up in terms of their confidence and their technical skills to do more challenging experiments.
Well, that's a great segue. I was going to ask you about mentoring, because you've been described as a great role model. Why are mentors so important to MCRs?
It is extremely important, because I wouldn't be here without my school teachers, without my university lecturers, without my supervisors who have supervised me for my research projects at the PhD level and the postdoctoral level. So, and these people help build confidence and help kind of transmit passion for science. And once you see they're passionate, once you see why it's important of what we do, that's how you kind of absorb their, passion and energy. And that's why, I want to have a career.
Well, it's very clear that you're very passionate and energetic about your science as well. Professor Seeming Man, congratulations. Thanks for joining us.
Thank you very much.
Next, we're going to catch up with a couple of the teachers that Seeming Man was just referring to, that are so crucial in engaging school students to choose a career in science. Mr. George Pantazis has received the Prime Minister's Prize Award for Excellence in Science Teaching in Primary Schools. Let's take a look.
My name is George Pantazis. I'm the STEM coordinator and learning support teacher at Marble Bar Primary School, located in Marble Bar, Western Australia. The population of Marble Bar is approximately 157 people, and at Marble Bar Primary School, we have approximately 25 students. It is famous for being the hottest town in all of Australia. At Marble Bar Primary School, I lead the integrated STEM program that combines Western pedagogies and Aboriginal cultural knowledge. We use two-way science, where the students become the teachers and they teach us about their rich Aboriginal culture. This is wonderful because First Nation science is the oldest science in the world. We use 21st century technology to acknowledge, respect, and celebrate First Nations culture. These technologies include virtual reality, drone aviation, and First Nations science and art. We've used virtual reality to take our integrated STEM program to the rest of the world, such as Europe, the United States, and Asia. More importantly, what this did was promote and celebrate our First Nations culture to the world. One of the most significant projects of the integrated STEM program is the digital First Nations seasonal calendar. The calendar depicts the seasons of the local region of the East Pilbara. Our next project is to create the first culturally appropriate video game, which links our First Nations culture and two-way learning. To be recognized in the Prime Minister's Prizes for Science is not about me. It's about my students, showcasing the First Nations culture and preparing them for their future.
And we'll be catching up with George very shortly. But first, let's take a look at Veena Nair, who received the Prime Minister's Prize for Excellence in Science Teaching in Secondary Schools. Veena is a teacher involved at Viewbank College in Victoria.
My name is Veena Nair, and I am the Head of Technology and STEAM Project Leader at Viewbank College in Melbourne. We run a lot of curricular and co-curricular activities. We offer emerging technologies such as 3D printing as a curriculum option for students from Year 9. Teachers are our nation builders, and we want our teachers to introduce our students to these emerging technology skills. Many people know about STEM, science, technology, but STEAM is with an A, which is for arts. It brings in out-of-the-box thinking, and it brings in creativity for students. Students need STEAM skills to innovate, to become resilient, and to take risks. One of our successful initiatives is the STEAM Club. STEAM Club offers students an opportunity to become change makers and use their skills for the greater good. As a part of the STEAM Club, we started an initiative called the STEAM Futures Conference, where students, teachers, and industry from Victoria come together and develop new emerging technology solutions and lesson plans that can be incorporated in every school. One of these initiatives is the Young Person's Plan for the Planet. This initiative allows students to use their STEM skills and enterprise skills in developing solutions for global and local problems, along with their peers in different countries. This Swinburne Youth Space Innovation Challenge offers our students a unique opportunity to work with space scientists in developing experiments that can be sent to the International Space Station. I've seen a large number of students take up engineering after doing VC systems engineering, especially females. To be recognized in the Prime Minister's Prizes for Science, I'm deeply humbled. I'm very grateful to my school, to my colleagues, to my students, and to my family.
And Veena Nair and George Pantazis join me now live. Good morning to both of you, and congratulations.
Thank you so much.
Good morning.
George, now you've been recognised for your leadership in Indigenous science teaching and community engagement. Tell us more about the work that you've done in this area.
Paul, it's been an amazing 3-year journey. So I was hired at Marble Bar Primary School in term 1, 2020. And on the staff development day, we were exposed to virtual reality. And light bulb went up and it said, you know, this would be a perfect engagement tool for the kids for STEM. And I had a conversation with administration there, my principal, and convinced him to purchase the VR goggles, and that was in late term 2. We started our first project, which was the digital Aboriginal seasonal calendar, in term 3, finished it in term 4 of 2020. We did our second project, which was Australian Animals and Aboriginal Arts. We showcased that at the 2021 Resource Technology Showcase at Perth Convention Centre. And yeah, it's taken off. We have been flying high on this amazing stuff. The kids engaged it, they love it.
And tell me about that, the way that you incorporate Indigenous knowledge in your STEM education.
So, beautiful. Yeah, no problem. So what we do is the teachers, myself, we actually become the students because the students teach us. It's all about the cultural knowledge of the Aboriginal students, and they know so much about their culture and so much about their land. They teach me, and it's been a win-win situation. I learn, they teach. That's it. They become the teachers. There's no other way to say it.
Well, what a fantastic way to do it, but also experience for everyone involved.
Oh, definitely. And the beauty about it is they get to showcase their culture globally, because with the galleries that we have in VR, we have collaborated with the United States, Europe, and Asia. So, you know, hats off to all the kids. They're the best.
Just fantastic. Veena, congratulations to you as well. How did you feel when you got the news that you had received this recognition?
I didn't actually believe it. It was very surreal. I had to stop my car and actually take it in. So it was very nice to get that.
And I think for teachers in STEM to receive this sort of recognition, I mean, it's such a crucial area. What we really need is, I think, for students and really all teachers to recognise the importance and value of
Absolutely. It's very important for teachers to be recognised, and it is very nice that we have an award that happens at the same time when all the scientists are getting rewarded and awarded. It just shows the importance Australia places on STEM teachers.
Yeah, fantastic. Now, the focus of your work has been around engaging students from diverse backgrounds.
Yeah.
How have you gone about that?
So I have actually connected. My journey actually started when I was in India, and I started developing a company which was deploying computers in poor schools and teaching coding. So that's where I started. But when coming back to Australia, my first job was at a Catholic school, and which had the large number of refugee students in there. And that's where I started in developing a STEM program that invited people to come and experience STEM.
Amazing. And you've managed also to increase the number of students who receive first-round offers to study engineering and technology at university. What have you found that works so well?
The most important thing is developing a course. In Victoria we have, and in other parts of Australia we do have a similar courses as well, but in Victoria we have what is called VC Systems Engineering, and this course alone is pivotal, has made it pivotal for students to get into engineering.
Well, it's and just a simple initiative like that then, you know, can lead to such dramatic results.
Yes, it actually, what it does is that because we have a course that we want to offer in VCE, we start developing courses in year 9 or year 8, and which can be pathways to this course, and that starts developing the pipeline of students in getting students into engineering, even, and most importantly, girls in engineering.
Yeah, absolutely. And I was in a meeting with the national committees that the Australian Academy of Science runs yesterday, and all the chairs of those national committees were saying we need to work out how to engage students when they're in school to choose STEM as a career pathway, and the work that both of you are doing are part of the answer to that question. So thank you so much for the work that you both do, and congratulations once again.
Thank you.
Thank you so much.
Thank you.
Well, that brings an end to our coverage of the Prime Minister's Prize for Science 2022 breakfast. Coming up at 9 a.m. Eastern Time, Science at the Shine Dome. 3 days featuring excellence in science, including the admission ceremony for our fellows of 2020, 2021 and 2022, lectures and interviews as well. Head to our homepage and you can find the link to that live stream at science.org.au, and stand by for more live coverage.